This is Hyperion, Meta's new data center. It's almost the size of Manhattan, and it's just one project. Amazon, Google, Microsoft, Meta, they're all in an arms race to build infrastructure behind AI. This year, those four companies will spend more money on AI infrastructure alone than every US automaker, railroad, and telecom company combined. And they're planning to double it next year. But here is what nobody is talking about. There is a single equation that determines whether this is the single greatest investment opportunity of our lifetime or a repeat of the dot-com crash. And once you understand it, you'll see every AI headline differently. I work at a company that's raised over $300 million to buy and transform companies using AI. So everything that I'm going to talk about is what I'm hearing firsthand from founders, investors, and advisors about the bets they're making right now. So let's break down the equation. So here's the equation. How much are companies spending to build AI versus how much they're earning from AI? That's it. CapEx versus revenue. In 2026, these companies are going to spend approximately $600 billion to build AI infrastructure. So the question then becomes, how much revenue do these AI companies have to make in order to justify that spend? Let's look at where we are today. Total AI revenue right now is approximately $250 to $300 billion. That includes enterprise software, cloud services, consumer software, all of this lumped into one. And the spend is approximately $600 billion. That's a 2-to-1 ratio. But that's just a static snapshot. A lot of the investment that's going into AI infrastructure is happening over time. And these companies are making their bets today for what's going to happen in 2027, 2028, all the way through 2030. The cumulative investment through 2030 is estimated to be $7 trillion. According to Bain, in order to justify that spend, the revenue generated from AI has to reach approximately $2 trillion per year for the rest of the decade. How big is $7 trillion? That's more than the Apollo program, the Interstate Highway, and the Manhattan Project, all combined. Now, that gap between revenue and AI infra is narrowing. Revenue is growing faster and faster, but the gap is still there and it's still enormous. But here's why you should pay attention. During the dot-com crash, this equation looked really similar. Spending was outpacing revenue, and it was backed by real technological change. The internet was important and was incredibly useful. But back then, the ultimate outcome was that it ended badly. So why then are the smartest investors doubling down on this AI infra build-out? The simple answer is because AI is real. And while that's true, I don't think that's a sufficient answer. The internet was real too, but this time there are real structural differences between the internet build-out and the AI build-out. The first is where that money is coming from. During the dot-com era, a lot of the money came from VC-backed startups that were unprofitable, that were pouring all of this money into the build-out. Google, Facebook, Microsoft, Amazon, these are some of the most profitable companies in history that are generating immense cash flows. And they're also some of the biggest spenders in AI. The second is that even though valuations for companies are elevated, they pale in comparison to what happened during the dot-com era. So where the money is coming from is one thing, but that's not what convinced me. What convinced me is what's happening between supply and demand. Today, we're severely supply constrained when it comes to compute. Every single unit of AI compute that comes online gets consumed pretty much instantly. When OpenAI tripled their capacity in terms of compute, they also tripled their revenue. The same thing happens with Anthropic. The more compute that they have, the more that they can service and deliver to customers. Their customers are begging them for more compute and more capacity. The reason that this happens is that compute is correlated with intelligence. So the more compute that you have, the more intelligent the models you can create and serve are, which means that the customers of OpenAI, Anthropic, and other model providers can provide better and better experiences and products to their own customers, which means they can charge more. So every time you increase the compute, you increase intelligence, which increases capability, and which increases the types of products and the amount that you can charge for products to the end user. On the other hand, let's think about what a speculative bubble could look like. In a bubble, money flows in, but demand doesn't follow. So you end up with excess capacity, empty buildings, idle compute, and warehouses full of product that nobody is buying. That's exactly what happened to fiber optics in 2001. Companies laid millions of miles of fiber optic cable, and most of it sat unused for almost a decade. What's happening, at least right now in AI, is that every piece of compute is spoken for. There is no excess capacity. Every chip is bought before it's manufactured. Every megawatt of electricity is claimed even before the power plant is built. And every data is full before construction has even started. And in my day-to-day, I'm seeing this up close, both as an end user of a lot of these models and also as someone who's productizing these models. The more compute that I have, the more powerful these products become, the more work that I can get done by myself. I have a nearly limitless appetite for compute. As the models get better, I use more and more of them, and they use more and more compute. In many ways, this does look different from the dot-com era. But real demand didn't save the telecom companies in 2000. The internet was also real, but many investors still lost everything. So what's the risk? Most takes on this topic are basically one of two cases. AI changes everything, so buy it now, or we're in this massive bubble and you should run as far away as possible. I think both are kind of lazy. So I'm going to try and lay out the actual risks of this AI build-out that you're seeing today. The first is debt. Despite having a lot of cash, a lot of the hyperscalers have raised a ton of debt, between $100 and $150 billion in 2025 alone. That's 3 times the average of the previous 9 years. And the projected borrowing of debt is expected to go up to nearly $1.5 trillion. And the capex of these hyperscalers is consuming 94% of their operating cash flow. And some of these companies are even parking their debt in separate entities, so it doesn't show up in their main financial reports. So while these companies are profitable, they're still seeking external sources of funding to keep building. The second is the depreciation trap. This one is quiet, but it might be the most dangerous. When you buy a piece of hardware, you don't count the full cost in year 1. Instead, you spread it out over the expected life of that device. The industry is spreading out the AI hardware over a 5 to 6 year time horizon, which means that these chips only need to earn back a fraction of what was spent on them in year 1 to justify the cost. But in practice, a lot of these AI chips could become obsolete in 3 years instead of 5 or 6. This could happen because every new generation of chips becomes so much more powerful and energy efficient that it no longer makes financial sense to keep running the old chips. So while you think that you have 5 to 6 years to pay back that cost of the AI hardware, in reality you might only have 3 or 4. And that gap between accounting and reality is where the trap lives. This means that the assets that these companies have might be worth less than they think. And when they're forced to write it down, it could hit their profits all at once. The second major risk is concentration risk. 85% of NVIDIA's revenue comes from just 6 customers, and 90% of the world's most advanced AI chips come from one company, TSMC. And that, until recently, only had one location, one of the most geopolitically contested areas in the world. If one major customer pulls back spending, or one factory has an issue, that cascades through the entire supply chain. TSMC and Samsung have lived through many boom and bust cycles with every technological wave, so they have a lot of scar tissue built up over time. Every time they're promised a world about how this time is different, and it turns out that this time isn't actually different. And if the people building the supply don't believe in the demand, that's also another risk. And the third risk is the one that perhaps keeps most AI researchers up at night, and that's the scaling laws. The entire bet behind AI infrastructure lies on just one question. The more compute that you give AI, the smarter that it gets. And that's called the scaling laws. But people are worried because this is starting to crack. There are 3 areas where you can think about scaling laws: pre-training, post-training, and then test time compute. You can kind of think about pre-training as setting for an exam. You give the model a bunch of information. You feed it every book, every blog, every piece of data that you can find that exists on the internet. But according to the co-founder of OpenAI, Ilya, pre-training as we know it is going to end. We've reached peak data. And this is because we've basically trained all the current generation of AI models on all the data that exists on the internet. The second part is post-training. It's kind of like hiring a tutor or doing practice tests after you've done your initial set of studying. You take what you've already learned from the first batch and then you sharpen it with targeted feedback. This aspect of scaling is still working. And the third part is test time compute. Instead of making the model smarter beforehand, it's kind of like taking extra time during an exam to think through an answer. So if you see when you're using ChatGPT or Claude, when it takes time to think, the more time that it takes to think, that's more test time compute that it's using. We're still early on in this, but it seems to be working quite well. The more time that you give a model to think through an answer and come up with a solution, the better it performs. So back to the equation that we talked about at the beginning of this video. Why does it matter for that? Well, test time compute uses dramatically more processing power. So even if we stopped improving the models today, even if we just gave it more compute or more time to think, that would burn considerably more tokens. And so the demand for compute will continue to increase, even if we don't release any new models. So even if the models of the future don't get any bigger or use increasingly more amounts of compute to actually create them, when we actually serve them to the end user, they'll use more and more compute. So that means the demand for infrastructure is still growing and that the revenue side of this equation will will continue to grow. So that's good news for everyone investing in the AI infra build-out. But if all three dimensions start to stall, pre-training, post-training, and test-time compute, then revenue will start to decline too, meaning the mismatch between revenue and CapEx will continue to diverge. So that's the bull and the bear case, for and against. But here's the thing. You might not actually have to predict where all of this AI infra build-out is going or whether revenue will actually catch up. What might be more interesting for the everyday person is to think about where the money is flowing, where the smart money is actually going in terms of these bets. So where is the $600 billion actually flowing? It flows through a supply chain. First you need chips, then you need somewhere to put them, which is the data center. Then you need to run power to this data center to make sure that everything runs smoothly. And then you have the AI models, the things that OpenAI and Anthropic sell to their customers. And then finally, on top of that, you have the applications, the things that end customers actually use day to day. At every layer, there is a bottleneck of some sort. And each bottleneck creates a different opportunity for founders or investors to take advantage of. And these three are the ones that perhaps matter the most right now. The first is power. It's an immediate crisis, especially for all the data center operators around the world. The AI chips that are housed within these data centers are power hungry, and they're getting hungrier and hungrier for more and more energy the better that they get. A current generation server rack, basically a cabinet full of chips, draws enough electricity to power about 30 homes. The next generation of chips, that might be 130 homes. Chips in 2027, that same rack space might draw power for 450 homes. And in 2028, that could be as much as 750 homes from a single rack of chips. The electrical grid was never built for this kind of demand, especially continuous demand that happens all day and all night, because it takes 4 to 5 years just to connect a new facility to a data grid. A lot of these companies, these hyperscalers, and the companies that are spending billions of dollars on AI infra build-out, are also becoming power companies. Google just bought a company called Intersect Power for around $10 billion. Microsoft just signed a contract to restart 3 Mile Island. And Amazon just locked in 2 gigawatts of nuclear power through 2042. And OpenAI's Stargate project just requested 2.3 gigawatts of power. That's the single largest order of any kind in its history. This is also redrawing the map. Texas is the new epicenter. It runs its own grid, has fewer regulations, and so it makes building data centers and connecting power a lot faster and easier. Northern Virginia, the traditional data center hub, is basically full. And the Middle East is emerging as a third pole. The UAE and Saudi Arabia have committed around $500 billion, hoping that this energy abundance that they have will put them at a permanent advantage in the AI race. The second major shift is how AI compute is being used. Right now, most of the computing power is going into the training phase, the building part of these AI models. But more and more, this is transitioning to the inference phase, actually serving the customers the AI models when they're being used. Why does this matter? Because inference, actually serving AI to customers, uses different hardware than that which is used to train or build the AI models in the first place. And these big hyperscalers and NVIDIA are spending lots of money to get their own custom chips specifically for inference, for serving these models to customers. Google already had TPUs. NVIDIA spent billions of dollars to acquire Grok, which has LPUs, which are custom made for inference. The third shift that's happening is thinking about how big AI could actually become. What is it actually replacing? Most people think about AI replacing software, and they've even created terms for this, the SaaS-pocalypse, saying that a lot of tools in the future will no longer be software tools, but people will vibe code them or create them internally at their companies for their custom use cases. And while this may be true in some instances, I don't think this is where the huge opportunity lies with AI. The great thing about AI is that it is intelligent. It can do things that are not deterministic, that don't have a strict if this, then do that. And so the true opportunity here is actually for AI to replace labor. Even if AI replaced every single software tool out there, it would barely move the needle for that $7 trillion bet that I talked about at the start of this video. Software only accounts for 8 to 12% of what companies traditionally spend. The real opportunity is in the other 88 to 92%. That's what companies spend on people. And if AI can capture this budget, this is where we'll see AI revenue actually catch up and exceed the AI infra spend that's happening today. We're already seeing this in our day-to-day at Beacon. In terms of my own work, AI has helped me take things that would take me 40 hours and take it down to 4 hours. Now I can just do way more things in less time. And the same is true for every single department across legal, BD, M&A, and engineering. We're able to do more with fewer people. That doesn't mean we'll spend less on people, but it means that our appetite for compute and for AI is increasing, and that hopefully we'll continue to be able to generate more and more revenue over time. And so, as our revenue increases, our appetite to do more increases, and our appetite for compute also increases. And that's ultimately how I think the equation between revenue and CapEx balances. AI doesn't just replace software, but it actually replaces work. And that market is 50 times larger than the market for software. So back to the equation, roughly $600 billion in infra spend versus around $300 billion in revenue generated. Although that gap has been getting smaller and smaller over the past few years, it needs to continue that way for the next few. So the next time you see an AI headline about a revenue announcement or an earnings miss, or somebody crying wolf about the AI bubble, come back to this equation and think about whether or not these two numbers are converging. And this gap is getting smaller and smaller. If you like this video, you'll love this video, where I break down the 5 ways that AI is fundamentally changing finance forever.